Is it? Okay.
Okay, so we're going to be talking about the tension and circular motion lab.
Okay, so the purpose of this lab is to gain a better understanding of tension force and to look at the magnitude and the direction of the force that must be exerted on a body to induce circular motion on that body. So
for tension, you would use, if you can see this, the clothesline with the shirt hanging from it. And to find the force, you look at, there's two springs on each side of it, and you would look on here and it reads in newtons, so that would be the force for force 1, and this would be the force for force 2.
yes. So yeah, then you would get a piece of string, attach it to a yardstick or meter stick, and you would put it across the little bar there, and the string would hang down in the center. That's the plumb line, and you would use a protractor to measure both of those angles in between the plumb line and then the string that has the force. So that is theta 1 and theta 2 for force 1 and for force 2. So that is what you would do for that. Okay, so far we've found F1 and F2 using the Newton scales like Taylor said. So to find F3, that is equal to the weight of the shirt. So you would take off the shirt from the clothesline and weigh it on the scale and change it to newtons. Convert that
Which
to
is mass times gravity.
newtons.
That's how you would get it to force, or to newtons. Yeah.
Newtons. Okay, so when you weighed the shirt and converted that weight to newtons, that is the experimental value.
And to find the theoretical one, you would use the two angles that you found, theta 1 and theta 2, and you would put them into the equation. You would do for the right side of the clothesline, you would do cosine of 50 degrees, because that's the angle that we found, and you would times it by force 2, which was found right here, and that was 8.2. And then you would add that to the cosine of 55, which is the left side, and times that by the force 1, which is 8.1, and that's how you find the theoretical, like the F3.
And then with both of those, you find the percent error, so just the experimental minus the theoretical divided by the theoretical times 100. So that is all you gotta do for part A, shirt on clothesline. Okay, so for part B of the lab, rotational motion, you're going to have a PVC pipe, a small little PVC pipe with a piece of string going through the middle of it, and one side is going to have a rubber stopper, and the other side is going to have a mass. And
to be able to swing it, like as you can see right here, you need it in a horizontal like rotation. So you would hold the string or hold the pipe like this with your elbow right here just to stop it from moving like this, and you would rotate just your wrist, and that would keep the string like staying in a horizontal motion instead of it like tilting or anything. So in order to stop the horizontal motion, whenever you're swinging it like this, there's a string hanging from the bottom, so you'll want to pull it while you're still swinging it, and it'll eventually just like shorten and come to a stop instead of it like hitting your head or anything. Like you don't want to just like let it go and it hit you, knock you out.
so the main point of this part of the lab is your partner is going to time how long it takes to swing 20 revolutions. You'll do that 10 times and then get the average time for the 20 revolutions, and then you'll also do some calculating to figure out the time for just one revolution. Okay, so there's also going to be a piece of tape on that string. It's called the flag.
And so your partner is going to use a ruler, and while your other partner is swinging it, we're going to measure how far the tape moves. So you're going to want to measure its highest position and the tape's lowest position.
You're also going to calculate the distance traveled in one revolution. So we already calculated the time for one revolution. So now the distance, so the circumference of the circle basically. So you do that with 2 pi r. Okay, so one of the main things that you see in this part of the lab is how a body will not move in a circle unless some other body exerts a force on it directed towards the center of the circle. So that, like the centripetal force. So you'll be seeing that, finding that.
So one of the important laws that's also going to be used in this lab is Newton's second law, which tells us that in order to have an acceleration towards the center of the circle, the body must be pulled or pushed toward the center of the circle. So the radial inward force is going to be F equals ma, which is mass times acceleration. So the Newton's second law can also be changed to mv squared over r, which is the centripetal force. So these were all the main points on how to do this circular motion and tension lab.
Yay. So the main thing with this lab is you're gonna have that contraption in your hand, swinging it, keeping a horizontal rotation. You're gonna time your Okay, so when you weigh the shirt and you convert it to newtons, that is the theoretical value. Dang it. Okay.
I wish I could put like tilting or anything, and I don't know what else.
To stop it.
Yeah.
Stop it.
To stop the horizontal. We can just cut. To find the theoretical one, you would use the angles that you found right here, theta 1 and theta 2, and you would put them in and do cosine of whatever angle you get times the force.
It's okay.
That's shit in the video.